Hello and welcome to session 259 in the AIsafety.com reading group. Tonight we'll be discussing the middle part of How Might We Align Transformative AI If It's Developed Very Soon by Holden Karnofsky. Holden Karnofsky is still co-CEO of OpenFill and co-founder of GiveWell, and we are taking the middle third. But I would like to start by just trying to literally answer the question that is posed in the title, how might we align transformative AI in the very near term? And I think, in fact, there is a, if not complete answer to this, then the obvious thing is we have some alignment techniques that seem like they might be useful, and we take a look at the existing techniques that we have and use the best one of these. So Evan Hubinger have written this wonderful post, an overview of 11 proposals for building safe advanced AI. It's 2 years old at this point, but it's really good. Just basically answering this question: if we had to do it now, what would be the best techniques for it? And I really strongly recommend this post. Of course, it would be nice if there was an equivalent post just 2 years newer, right? That also had things like listing latent knowledge. And I think that would be a better, if not a better way, then certainly a different way to approach this entire question, to simply start with these 11 techniques and try to evaluate which are good, which are bad, which can be used in this particular setting, and in particular, is it possible to combine some of them, which I think would likely be beneficial. Okay, now for the actual text, key facets of AI alignment. Remember, we saw last time that the four properties that we really want our AI system to have is that it should be value aligned, it should be honest, corrigible, and legible. Now, a key thing in order to get these properties is that the reinforcement that we provide, the supervisors provide, must be accurate. In general, the idea is that the supervisor, remember, we're doing this near casting where we're assuming that the technique that works it's called human feedback from diverse tasks. So that means, by definition, there is a supervisor that is giving human feedback, that means that since we already know that it is feasible to give human supervision on the object level, like is the AI capable, then we might assume that on the four alignment properties, human feedback is also a viable or not even a viable strategy, but the best strategy, since Magma, the AI company, has in fact been able to beat the competition and be first to transformative AI. And I want to highlight here that is a really big assumption, that human feedback can be scaled to this dramatic extent. And I think that is, we've seen obviously a lot of unsupervised learning, and that seems to me to be some of the most impressive capabilities right now. So the example that Holden Karnofsky is using is on the task that is generating some computer code that humans have specified. And is that a task that humans can provide reinforcement, can understand? Well, right now it is, because humans can understand most code, but it seems like if we get substantially more advanced techniques, then evaluating whether code is correct or not, it will in fact turn out to be really difficult. And we're not that far from Copilot generating code that is above the human level in general. So on this question about what is the code, how well does the code work, we can do things like we can run it, and we can do automatic tests, and we can read it. And by definition, again, since we are assuming that Magma has figured out how to scale human feedback, then we can just test the performance directly by assumption. How about legibility? Again, for computer code, it's quite possible that we can just see, is this understandable? And that's probably going to be one of the key parameters. So sure, that seems like something that we can check if on the on the simple level where a supervisor can look at this code and say, yes, I do understand it, but we don't get anything deeper with, is the understanding actually correct? Just the supervisor's opinion. Is it value aligned? Holden-Karnofsky says somewhat. I am a bit less optimistic about like to what extent are human values expressed in a if statement that is something about sorting integers or something like that. But you could argue, I'm sure. For honesty, well, we can see, does the AI system is it reporting its true best guess prediction about what the code would do? That's to my mind just a restatement of the problem. Really, we're not digging down deeper into how will the supervisors figure out whether the predictions that the AI give about its code are its true best guess predictions, except just checking whether they are actually true. But it can't do anything about deception or anything like that. Or at least there's no description here of how you would provide accurate reinforcement that checks if something is deceptive. Also, I'd like to notice that among the 4 alignment properties, the one that Holden-Karnofsky is not discussing is corrigibility. And there is probably a good reason for that, and that is that in this specific case, corrigibility is very, very hard to check. Like, if you have some computer code written to a specification, does that mean that the AI is corrigible or not? To my mind, it's just completely impossible to answer this kind of question. You cannot give accurate reinforcement on this part, except if the computer code has to do directly with whether the AI can change its mind. But almost always that will not be the case. In particular, of course, with the accurate reinforcement, one of the key things we want for the alignment point of view is to not reinforce unintended behavior. And in one of the key unintended behaviors are things like exploiting the supervisor's weaknesses and not just illegibility or things like that. So how can we do that? Well, we can look at the reinforcements really, really hard and try very, very hard to ensure that they are as accurate as we can make them. And we can also skew them somewhat in that if we find something that we are barely able to detect is actually bad, even though it looks quite good, then we should skew our reinforcement and give that a huge negative value. But of course, doing this is bound to cause dramatic less competitiveness, and also the requirement to look really, really hard and work really, really hard on this technique is just something that it requires a low number of episodes. Like if you have hundreds of thousands for each supervisor, then you just can't spend that much time on them. And I think this is really at odds and highlights the problem with this human feedback from diverse tasks that is assumed here. Because if we're assuming that human scalability works really well, then if you want to put an enormous amount of effort into this, then you need to find a really good way to scale human feedback. And I think it stretches credibility if you want only a very low number of episodes. Another facet you would want is out of distribution robustness. And the key out of distribution task that we're thinking about is like you have the AI that is being trained and in test, and then suddenly it's in deployment, and in deployment it has the new option to take over the world that it did not have previously, and that's what we wanted to not have. There are a number of known problems with this. For instance, the SHA-256 problem that Holden-Karnofsky isn't really referring to in any specific way. Maybe he's unaware of the problem, maybe he's assuming that it can somehow be solved. One of the ways we could do this is we could simulate the out of distribution, meaning that we just tell the AI, while it is in training, that it is not in training, it is being deployed, and try to cheat it to do that in some kind of adversarial sense. So we try to set up something as as tempting as possible to try to push the AI into situations where it would try to do a treacherous turn or something like that. And the problem, of course, in this is that we are explicitly telling something that may be substantially smarter than us a falsehood, and that pits our intelligence against the intelligence of against the superintelligence. And trying to convince a superintelligence something that is just blatantly, obviously not true might be really, really hard. So the adversarial training, one of the things we want to do, of course, is to look at these four facets, these four alignment objectives: corrigibility, value alignment, legibility, and now I already forgot the fourth, and try to see if there are some of these objectives that have somehow been learned. Another way is to dig down more into what are the unintended behaviors actually, and teach the AI details about this in order to see whether it has this. I think that seems quite unsafe to me. And teach it that apparent opportunities to get reward via unintended behaviors are illusory. And I think this, trying to convince an AI that is not in a box that it actually is in a box, is really, really hard to implement. Like, it's trying to convince someone who is smarter than you of something that is blatantly untrue, and it seems really, really hard to do that in a consistent way that they can't just easily see through. One of the things we can look at is relaxing the problem somewhat, and instead of just looking at we want the AI to not do a takeover, then we can look at a larger class of problematic behavior called the always undesired behaviors. And Holden-Konofsky is very optimistic about this, say we can avoid this with very high reliability. And my thought is that it's going to be a lot harder than Holden-Konofsky expects. Very high reliability is a very difficult bar. In particular, like cheating someone who is smarter than you seems not like something that can work infinitely. At least at some point the other person just becomes so much smarter that then cheating them just becomes infeasible. So the always undesired behaviors are dishonesty, illegibility, and illegibility, I would like to point out, is not obviously something that is always undesired. Like, again, with the example of computer code, sometimes we always prefer that it's legible, but it's not like we want as legible as possible, because we have a number of other requirements at the code. We are not trying to maximize legibility. We are trying to actually get the job done. And sometimes there just are no, like, you would hope that there is a really, really simple way to prove the Riemann conjecture or something like that, but we want to know whether the Riemann conjecture is true. And so in that case, we might not really train very, very hard for always having illegibility undesired. So I don't think we can do it like this. Again, incorrigibility is something that is always undesired, but like, how would we go about that? Taking steps towards disempowerment is, of course, also something that is always undesired, but again, it's hard to do in reinforcement once this has actually happened. Falling for honeypots is something that we'll get back to, and falling for misleading info. Like, if you tell the AI something that is wrong, then we'd want the AI to figure out what is the truth. And I think this may be, in fact, at odds at some of the relaxed adversarial training we'll look at later. And certainly this seems to not be related to alignment. This seems to be just making the AI smarter. The key kind of training that we want to avoid is, in Holden-Konofsky's word, results that are incorrect but convincing to most supervisors. This is something that can be interpreted in two ways, depending on whether it hinges on most. Like, if you have something that 9 out of 10 that fools 9 out of 10 supervisors, but the 10th supervisor sees through this and tells the other 9, and then it gets a very low reward for that. Then that's one way of seeing it. Another is that we look into the AI to try to figure out if it's honest or not, and see whether it's making something that it knows is dishonest, that is incorrect, but believes will be convincing to the supervisors. I think, in fact, both techniques may be very useful. It's just we need to disentangle these two things. One of the key things that are probably interested are what Holden-Karnofsky calls exotic cases. I have put in here a quote by Eliezer Yudkowsky. I think it's really relevant to this question, in that all this task of trying to figure out what is this AI that we're building unaligned. If we figure out, it is in fact unaligned, then going from there to making it more aligned, we obviously can't just train away the symptoms. So what do we actually do? And I think this is something that Holden-Karnofsky should think way more about. Let's get back to the exotic cases. One way to find cases where the AI behaves possibly in a bad way is to do the standard kind of adversarial input thing that we are doing right now, making small permutations and see which triggers the AI to do something strange. I agree it would be a nice thing to do. I'm not entirely sure this is worthwhile, because we have a limited budget. Magma may have even a sharply limited budget for alignment work, and whether this is worthwhile is questionable to me. Another way to find exotic cases, which really is things like the treacherous turn, is to condition on there being some kind of fake path to a takeover. As I've said before, making an illusion that is impossible to see through is probably really, really hard. And just in order to figure out that it's an illusion, you only have to find one inconsistency. And if you go looking for inconsistencies in something that is totally fake, then you're more likely than not to find it. Holden-Karnofsky also admits that he's very uncertain about, to what extent will this actually work. One thing that is at least clear is that it will be possible for Magma to spend a lot of effort in trying to make this possible, in doing adversarial training. So whether it will actually help is an open question, but you can spend a lot of effort there. And of course, just at some point, once the AI becomes smart enough, then it is insufficiently reflective. And at some point, even if you get really good at faking things for the AI, then for it to realize that, Holden-Karnofsky is again really, really optimistic. He says it would take someone who is vastly super intelligent AI to realize that the path to take over that is being presented is in fact not real, but something that is an adversary has placed in front of it. I think that is unfortunately very unlikely, and unlikely to require a vastly super intelligent AI, because the AI is reading what we are reading here, and so it will obviously suspect this, in particular if it has encountered it often in training, and evaluating this, evaluating a true fact, in general does not require a vast super intelligence or something like that. I think Holden-Karnofsky is way too optimistic about this. A third facet of alignment is preventing exploits, and one of the ways to prevent exploits is to just put the AI in a box. That's like the classic way. That might make sense in some cases, and does it make sense in this case? Right? This is the kind of thing that I would really like to have some details about. Obviously, when you want the AI to be transformative, then it can't be in a box. And if you wanted to do something like the hardening suggestions that we saw last time, then it can't be in a box. But an advisor or coordinator may be in a box. It could make sense, at least in some cases. So the goals of the AI, normally I would, if I were describing the goals, I would start out with Omohundro's basic AI drives. But the three goals that Holden Karnofsky are starting with are deception, manipulation, and disempowerment of humans. And the means to this are things like hacking and psychological understanding, the cognitive limits of humans, and different kind of side channel attacks. The counters to these are excellent cybersecurity, selecting and educating supervisors, having a vetting, like you get a security clearance of the supervisors, and limiting the autonomy of the AI. Of course, going to a normal company and say you need to have excellent cybersecurity is a really, really big ask, and a lot of people don't realize just how difficult it is to get excellent cybersecurity in this sense. But it may be required, and I could easily see that Magma would be at odds not just from the inside, from its own AIs, but also from the outside, like government or competitors, who would be very interested in penetrating to some extent. And we want, in particular, to ensure that the training doesn't doesn't accidentally cause the AI to become more capable on these behaviors. The final way of ensuring this alignment and safety is by doing testing and threat assessment, like figuring out how do these unintended behaviors arise. One of the key ways is doing audits. Holden suggests that for some of the AI actions, we just put 100 times as much effort on scrutiny. So we take 1 out of 1,000 actions done by the AI, and we really, really drill down into figuring out, is this actually deceptive in some way? I don't expect this to be a good strategy, because I think that an AI that is trying to do a treacherous turn would do something innocent in 99.9% of the cases. And that means that in order to catch the single action that is in fact disempowering, what you need to do is to focus widely, so you ensure that that all actions are audited instead of just focusing on very few. Holden Karnofsky also suggests some randomized audits, and I think that may be better if it's done in some kind of combination. So you take this audit, you have like the supervising budget, and then you have an audit budget, and some of it you spend on the most suspicious actions, and some on the randomly selected set of actions. I think something like that may be better. One of the things that Holden Karnofsky is also suggesting, we'll get back to this a lot more next time, is to use, once the AI is going through this intelligence explosion, we may just the AI now may be substantially smarter than the AI a couple of days or weeks ago, and then we may use that one to examine the earlier weaker AI outputs, and that may be useful. We could also make the auditing AI get more compute, and we could do interpretability as part of the auditing processes, but that's a problem. That's something that have known problems, of course, in that you could just train it to appear honest. Some kind of multiple level evaluation where you're perhaps only evaluating test and not in training may make sense, and yeah, I think it basically does. It probably only catches unintended training of deceptiveness, but that may also be worthwhile, and in particular using another AI to check whether the previous AI was deceptive is something that will only work if the new AI is reasonably aligned. So that is an obviously problem with this. Holden Karnofsky again is really optimistic. He believes this is likely to work by default, and that it requires a pretty extraordinary level of capability to anticipate that there will be some kind of test. I think this is very wrong. I think the text that Holden Karnofsky is writing is explicitly something that a future AI will be trained on. So that means the AI knows that it should anticipate this because it's in the training set, because Holden has explicitly told the AI that. And I think we need a principle somewhat on an analogy to Kirchhoff's principle that if you have an alignment strategy that only works if the AI does not know about it, then it's a really bad strategy. And like, you certainly cannot publicly discuss a strategy that will not work if the AI knows about it, because the AI is of course going to be trained on everything. Unusual incentives is another strategy. I think this is what people normally call honeypots, which is like, let's say you have an AI and you believe it will not try to take over not just the world, but in particular it doesn't want to take over its environment, and you give it the option to control the environment, but not the option to take over the world. Of course, you really don't want to give it that option, right? But the option to control the environment, you give it that, even though you believe it will not take that option. And then you add dramatic more incentives for the AI to take over its environment. Like you say, if it takes over its environment, it will get compute for $10 million and can use that to just maximize its reward function. Then you see if it does it. I think that is kind of a strange thing. Like, if the AI will not take over the environment, if that's done by incentives, then obviously by changing the incentives, then eventually the AI will try to take over its environment. And also, this is something that may not matter very much, in the sense that the potential incentives for taking over the environment are likely to be dramatically smaller than taking over the entire universe, because the things that that Magma can use for a specific small part of their alignment project is just dramatically worth less than the entire universe. Another thing we should do in assessment is to explore alignment, and not just always using the most aligned AI we have, but try to train, especially with the weaker AIs, without some of these alignment techniques, varying the alignment techniques in different ways, to get some understanding of how they relate. And of course, if that is something that we want to do, then that's something that we could in theory do now, because the AIs that is substantially weaker are in fact AIs that we have right now. So this is not something that that they should wait with doing until this. And of course, why are we not doing that right now? Well, because we can't. Like, the alignment theory field is just far from being able to say this AI is 38% aligned and this AI is 57% aligned. We totally don't have any metrics like that right now. So just because Magma somehow gets a more powerful AI, some kind of breakthrough, then like the assumption that they'd be able to go back to the level we are now and say anything intelligent about that seems like a very big and strange assumption. And the hope here from Holden-Karnofsky is that we can get some kind of quantification of how well do the different alignment techniques work, in the hope that we can get something like scaling laws between the alignment measures. I think it's very unlikely we'll get something like scaling laws. Those are by compute and trying to extrapolate towards the future, and I think like the new abilities of AIs as they become more powerful are very likely to be disjunctive, and the AI in particular are going to be able to see through some of our attempts at misdirection. And Holden-Karnofsky is also somewhat less optimistic about this. He says it probably only works for AIs that are lacking situational awareness, and I think that is true. And I think also, if we are talking about transformative AI, then transformative AI almost by definition will have substantial situational awareness, right? Because if it's AI that does not have situational awareness, then it's not going to be transformative. So I think almost by definition this is not going to work. And but that's not even the key problem here. The key problem is that misalignment is going to be really hard to identify and put any kind of metric toward. The final suggestion, penultimate suggestion, is to create some kind of dedicated assessment team. So should it be a dedicated team, or should it be like more broadly distributed in the organization? I think it's a question. It's a political question, obviously. How much political capital does the alignment team at Magma have? Does it have enough that you can make a very strong dedicated assessment team, or do you need to organize it in some other way? I could definitely see problems with having it as a separate team. So what would be the tasks? One of the tasks would be to analyze the overall setup, estimate the odds of an existential risk in general, both on the action risk and inaction risk. I think that's going to be really hard to get meaningful probability on this. Right now, the distribution on risks given by AI safety researchers are like really wide. Some people believe that there's 99.9% probability of a disaster, and some people believe 0.01% probability of a disaster. Like, it's a really wide distribution right now. The assessment team can do interoperability work, they can monitor activity logs, they can interview the staff, the rest of Magma, do experiments, hire super forecasters, and finally use AI assistance in this. And this is probably something we're going to talk a lot about in the next session, whether we should in fact expect that to be a substantial help. John Wentworth has a nice analogy about this, that this is like getting Godzilla to fight Mega Godzilla. And that is a thing that makes, in general, plants much more brittle. And in general, if you think that monitoring activity logs is something that is so hard that you can't do it, then just saying, oh, we'll use the AI as assistants to figure this out, seems like kind of a cop-out and very unlikely to work. Like, if that was going to work, then why doesn't it work when humans are looking at this activity logs? I think that's it is certainly possible, but it's I agree with John Wentworth that this makes the plan a lot more brittle. The final thing is the question: what do you actually do if you figure out there is a risk? What do you do if the AI that you're training seem to be unaligned? I think this is a core question and something that should have much more than one paragraph assigned to it. I think this is a really big question that needs to be answered. Of course, the thing you could obviously do is to just train it away. That's very unlikely, and I think Magma in this case is assumed to be sophisticated enough to certainly not want to do that. So what will they do? They might be trying to find fundamental improvements to the alignment problem, just doing basic research, and that's like the kind of research that we ought to be doing now, because we are expecting that we will find some kind of risk. So why are we not doing that? And another thing is they could warn others of the danger. And that's something that I would like to have way more discussion of, because who do you warn and what do you tell them? What is like the political consequences of telling different people, and can people keep secrets, or are you forced to share it maximally? Do you request aid from the government? Do you request aid from the general public? Do you try to like, what do you do that? I think it's a very interesting question and a crucial question. If a company, Magma, is building something that looks like it can be transformative, and it seems like they are unable to reduce the existential risk sufficiently, like, what do they actually do? Who do they tell? I think it's really important, and we will see in next time what precisely Holger Kanofsky suggests in that case, and I hope at least he has more about that. Thank you, and see you